Welcome to exploiting bug reports in the games industry. Before we start, make sure you silence your phones and all of those usual warnings. And I would like to thank the organization for accepting my talk and letting me come here and make a fool of myself. It's my first time doing a talk at a security conference. So this is this is going to be fun. I am not nervous at all. No, this is not a thing. Okay, let's do this. My name is Andrea Gaita. I'm from Portugal. I live in Denmark. I am currently freelancing, and before that, I was a tech lead at GitHub doing source control tooling. I was a runtime engineer at Unity working on game engines. And before that, I was working on the Mono project at Novell and Xamarin. A lot of open source, a lot of cross-platform development that I've done over the years. So the security is kind of a recent thing for me. I've always been interested in it, but I've never really had the time to go more in depth into it until I went to Blackhoodie recently and finally took the time to, this is my second Blackhoodie, and first Blackhoodie finally took the time to, okay, let's see how this is going. And it's fun. I'm a cross-platform engineer, so I do tools, libraries, runtimes, and bindings. I usually, basically, I take something that someone has built for one platform and make it run on another platform, most of the times without being able to recompile the original application. Because it's just, sometimes I can recompile it, other times not. So it's a lot like malware reverse engineering, only the thing that's reverse engineered is not malware, it's just an app, and you're just trying to figure out what the app is expecting, and then you fake everything around it, and at some point, if you fake enough, it will work. That's pretty much what I've been doing for 10 or 15 years, basically. And for that reason, I work a lot with all kinds of platforms. This is just a sampling of stuff that I've done. And I don't really care what OS I am on most days. I have a Windows machine today because we're talking about games, and games are on Windows. Otherwise, I would have a Mac because Macs are for talks. So, you know, it's fun. Security and malware and reverse engineering, which is my first Blackhoodie workshop, is surprisingly relevant to all of this stuff that I have done. I was very surprised when I started doing reverse engineering for malware and go like, oh, I know this. Okay. It's just the same thing with slightly more evil code, but otherwise not too different. Anyways, enough about me. Let's talk about what we're talking about today. Today we're going to talk about game middleware companies. We're not going to talk about companies that make the games. We're going to talk about the companies that make the software for the other companies that make the games. So it's game middleware, game engines, and most specifically commercial off-the-shelf software that is used by game development companies to make games. And we're going to talk about vulnerable processes that these companies have, the processes that are vulnerable, specifically bug report systems, and why and how they are vulnerable to attack. So before we go into the bug reports, let's talk about game engines, what they are, and why these things work the way they work. I'm going to focus on popular game engines, i.e. game engines that are accessible to anyone to make a game. There's a lot of different types of game engines. There's teams that make game engines in-house. They're custom built just for the game that they're making. There are other, and they might or might not sell these game engines to other people. Sorry, I clicked on the thing. They might or might not, sell these custom game engines to other teams to make their games, but it's a custom game engine. It's made for them. They're not servicing users. The users are themselves. And then there's commercial off-the-shelf game engines that you can just get and make. That especially the one Unity and Unreal, which we're going to look at today, which have a user base in millions of users, basically, from the student that's making a little game to teams of hundreds making their games. So Unreal, Fortnite is made in Unreal. Unreal is the engine made by Epic. So if you go on Twitch and you see all of the games, a lot of them, mostly FPSs, are made in Unreal. And then Unity, Hearthstone is made in Unity. On the top 10 mobile games that you can see in the App Store or Google Play, 7 of those are going to be made in Unity. So both of these engines have huge user bases. They're free for anyone to access. And they have partial or fully available source code for users. In the case of Unreal, the source code is available for anyone to download once you create an account with Unreal. It's on GitHub. You can grab it and see it. And if you download the Unreal Engine to make a game, when you're coding the game, you'll be in Visual Studio and you'll have the source of the engine right there. So you can see everything that it's doing and you can do whatever you want with it. Unity has the runtime is proprietary, but they have a lot of open libraries with source code available. And if you pay them, they will give you the source code. But in general, all of these are very publicly accessible. So, what is a game engine? We need to kind of understand what it is and why it's built the way it is so that we can figure out why the bug reports are problematic. So bear with me a bit on this slightly deeper dive. So game engines kind of evolved from an abstraction on top of whatever platform you're trying to make your game on. Initially, people making games will have, like, I'm going to make a game for Apple II, I'm going to make a game for early versions of PC or whatever hardware was currently popular at the time. I'm just going to hard code everything because this hardware, I know exactly how many colors the display can have, I know exactly how much memory it has, how fast the disk is, or whatever. All of these variables that are important for a game, people would just make a game and hard code it. There would be an engine there, but the engine would be the game itself. Of course, it takes 6 months to do this, and then by the 6 months they are shipping, there's another new hardware platform that's better, the new console. And now the publisher goes like, hey, this game is good. Can you make it run on that thing? And that thing is a completely different hardware, completely different specs, completely different memory. Some things work better, some things work worse. Now we need to re-implement the engine on the second hardware and rinse and repeat for every single iteration of every single hardware that you can possibly run a game in. So at some point, game development houses started abstracting their own code because they kept porting and reporting all of these games. And an industry was born just for porting games, companies that specialize in just this. And to make it obviously easier, and your developers, you get this, you kind of build an abstraction on top of it. So you kind of hide the platform a bit more so you can target it without losing performance. And performance is key for this type of code. You need to have the fastest data access, the fastest memory access. Those pixels and that image needs to get on that screen in that amount of time. This is relevant even today. It's not just a thing that was at the time when we were hard coding all of this stuff in games. If you have ever put a VR headset on, you might have gotten nauseous and sick and kind of had vertigo. This is because studies have shown, as in people puking, and then okay, this is a good study, that if the time that it takes the game to say, I need to show this pixel, the time it takes for the game to make this instruction to the pixel actually showing up in front of your eyes needs to happen in 16 milliseconds. More than that, you'll get sick because your eyes are no longer reproducing what your brain expects to see when you move your head. So if you move your head, things need to move in front of your eyes. If that thing doesn't happen in under 16 milliseconds, you'll get sick. And some people, it's less than 16 milliseconds, it's 10 milliseconds. So your entire logic for your game, figuring out what to show on screen when in double vision, because you have two eyes, so you need to render this twice, slightly separated, so that you have depth perception in VR. You need to figure out how much the head moved, calculate what you need to show on the screen, and send that to the headset in under 60 milliseconds, full round trip. So it needs to be pretty fast. You can't be loading things from disk when you're doing this. All of your memory needs to be aligned so that the only thing you spend time on is literally show this now. And it's 60 milliseconds. It's not that much of time. And this is 60 frames per second. So the minimum. Ideally 90 frames per second for VR, but 60 frames per second for games is the most common thing, right? So this stuff needs to be fast. So you're abstracting your platform, and now you have your game engine runtime. Your game engine runtime is doing all the work of abstracting all this hardware for you so that you can run your game on multiple platforms, making it fast. The languages that are selected for the game engine runtime are obviously languages that are going to be optimized for this type of fast access. C, C++, anything that you can get that you can compile directly to assembly, that you can have optimizations, that you can access memory directly, that you can align data in memory, all of this stuff is essential for the tooling that the game engine needs to be fast, right? The problem is that a game development is not a game engine. This is the people that make games. There's producers, there's sound designers, game AI programmers. There's like 3 engine programmers in there. Those are the people that know how the engine works and how all this tooling works and all the compilers and all of this stuff. All the other people are not doing this. They're building content. They're building experiences. Games are design. You're taking input from a person, the player, and you're building interesting experiences. You're building narratives. You're building your artists and like animators and everything. These people are not coding an engine, and the tools that are used, the languages that are selected for the engine are not appropriate for these cases. So game engines have evolved in multiple layers. Above the game engine basically shows you, abstracts away, gives you all the core systems, gives you the physics engines, audio, all of the basic tooling, and then exposes that with other languages. C++, Lua, and C# are very common. It's a layer that sits on top of the engine that people are going to use to build content with, with languages and processes that work. For instance, if you've ever played Uncharted, it was all scripted in Scheme, which is a Lisp variant. The engine is not made in Scheme, but the designers all worked in Scheme. And I asked the lead programmer of the engine, how these people are not programmers, they're designers. How did they find it hard to program in Scheme? He was like, yeah, no, they've never programmed in their lives. For them, it's easy. It's just trigger an event and respond to the event. There's no side effects. It's just response. An action causes a response, causes an action, causes an animation, causes an input, causes something. There's no side effects, no memory access, no global states. They're just reacting to things. They're just modeling the system. And so people build a game on top of these scripting layers, and all of these engines have evolved over time to have this separation between the core stuff and the game content, so that you don't need a game engine engineer to build a game. You don't need to know how all of this low-level stuff works, and you don't want to go in and change the game engine in order to build your content, because then you're more worried about breaking the engine rather than building your game. So these are the way that modern engines work, and this has a nice feature that it allows you for real-time visualization of your changes. You can change your game code and you immediately see the effects, because the game code is completely separate from the engine. The engine is running underneath, and the game code can be reloaded at will. Recompiled, reloaded, interpreted. It's a VM that's running inside the game engine that you can just restart with all the state, and you see everything going. So it's very fast for prototyping, basically. So all of this is very abstract. So I'm gonna show you a game engine real quick. So this is a game engine. This is Unity. This is just an empty scene. And Unity is a C++ engine with the scripting language, one of the scripting languages. You can have whatever scripting languages you want. It doesn't matter. As long as you have the engine can run the language. It runs .NET mono in this case in the runtime, so any language that targets .NET you can use. So in this case, the default is C#. So because of all of these nice facilities for hot reloading, I can just go and change. This is the script that I have, like right here in Unity. And if I uncomment this, and you keep your eye on the menu on top, Unity is recompiling, and now there's a menu. So the way that Unity works is the entire editor is hot reloadable on the fly, because the entire editor, the runtime, the editor is a game, just like the game that's running. And you can do whatever. You can recompile it. You can add things. Everything that's on the C# layer, you can do anything with. So you can just completely recompile the entire editor while it's running, and you see the effects. You can obviously you do this for building custom tools while you're building your game, right? Like custom level designers or custom importers for your text or all of these things. You can just customize the editor to have the tools that you need to build the content. So you as a games tool engineer would build tooling that then the narrative designer would go in and use to add all the dialogues in your game. So all of these things are just an iterative prototyping approach to building content. Equally, Unreal is the same thing. It just uses C++, but otherwise it's exactly the same concept. They just chose a different language to host their data in. You can just you can extend the editor, you can add features to the editor, and then you can do the same with the game. And the editor has an editor mode and play mode. In the editor mode, you're building your game. In the play mode, you hit play mode, and you can see your game live in the game engine. So, just going to let that open. You can open that, and we're going to go back to our presentation. Thank you. Right. Sorry, it completely forgot that I was doing things. Over here. We'll continue to be here. There we go. Why can't I? This work? Sorry. Yeah. Okay. The present. I lost the presenter view. It's fine. Okay. So that was the game editor. So bug reports. So having all these hot reloadable features makes game development really, really, really fast, and prototyping. It's amazing for designers that need to just build things and not worry about all of the details. But what happens when you have a bug? Not on your game, but in the editor itself, or in something that the game engine is doing wrong, which happens a lot. The reason why Unreal was not running because I forgot to run it. It was because I had to shut it down, because every time my laptop sleeps, it crashes. So you know, there's bugs. There's open issue trackers where you can see all of the bugs. And when game development happens, teams will lock down a version of the game engine that they're using so that they don't have to deal with potentially breaking changes whenever they update their engine. Because again, they don't have expertise. They have to spend a lot of time trying to figure out what changed and what broke their game, and they need to ship it. So they will lock down a version of the game engine and run with it until they find a bug or are forced to update. And when they find a bug, let's say you're a project maintainer and you have your project on GitHub or somewhere, and someone opens a bug issue, right? And the traditional thing to do is describe the problem, and you describe steps to it. And then someone opens an issue report with some steps into it and a zip file of a bunch of binaries, source code and binaries in the zip file. And they say, to reproduce the bug, take this zip file and run the code, and run it. Would you do it? Is this a thing that you would do? Probably not. I'm assuming not. So now imagine that you're making a game and there's a bug in the editor, the compiler, somewhere that's breaking your game. It's not your fault. Something is broken and you have to report it. The problem is your game is 5 gigs if it's a small game. Small game. The smallest game that I've ever worked on had 3 levels. It's 2 gigs. That's just all of the components for the game to run. And somewhere in there, there's a bug. And you are on a tight budget, tight schedule. You need to get this fixed. So you need to open an issue to the game engine company so to go like, hey guys, this is breaking me, please fix it. Here's my project. That shows what the problem is. And if you think that's weird, no, that's actually, oh, it's not working. Sorry. Yes. Okay, this is the actual, like, the way to report a bug in Unity. Like, you go and report a bug, and it literally adds your project to the bug report by default. That's what it does. And that's it. If you're nice, if you have a project that's 5 gigs, there's no limits to the sizes of uploads that you can send. But if there's a project that's 5 gigs, that's probably a lot of stuff. And if you want to have it fixed, you're not going to send your 5 gig projects. You're going to try and trim down to find like the parts that are actually causing it without sending your whole project. So in reality, you're going to send one of the levels instead of the entire level of the game. It's going to be 1 gig instead of 5 gigs. On the other side, Unity is going to have an attachment with all of this stuff. And if you think that's because Unity is doing things silly, this is the web page where you submit a bug report to Unreal. And instead of uploading a zip file, you can just give them a link to the test project. So, which is nice, because at least there's even less limitations on the sizes of things that you can download. Because the problem is, these things are very complex systems with a lot of interactions. Drilling down to the single line of code that might be causing this is impossible. It's about interactions. It's about a shader compiler for some obscure NVIDIA card. It's something. And it's really hard to track down. Engine developers can probably track it down. The user that's trying to get their thing working is going to have a really hard time giving you a very sanitized piece of information that describes this bug. So the bug report is going to have a full project. So So this is where things, the nice hot reloadable mechanisms, start becoming an issue, which is all about this talk today. You're submitting a bug report. All of this stuff is going in. And the first point in the triage process is QA, because there's so much content going in every day. Obviously, this is not going to go, like, developers are not looking at this stuff directly. There's triage, and there's QA. And QA is going to look at it and validate that there is a bug that is not by design and that is reproducible with the steps that the bug report had. Of course, ideally, they do this in a VM. And in practice, having VMs spinning up for every single project so that you can sanitize the inputs, basically, and make sure that whatever's running is not problematic, is complicated. Like, you have to have infrastructure in order to do this. And sometimes you can't do this in a VM, because VMs are abstracting the hardware. It's another layer of abstraction on top of the abstraction that the game engine is already doing. And this might be a problem on Windows with this device driver loaded, or that device graphics cards loaded. Particularly graphics problems are a problem, because the VM is going to abstract a generic graphics card. It's not going to be running on an NVIDIA 1080. And it's going to do a lot of things that might or might not trigger this bug. A lot of the issues could be done in a VM, some couldn't. And in any case, you need the infrastructure in order to actually do this in VMs reliably. You need the processes in place to do it. And some of them run on a VM, some of them don't. But if the bug is valid, and QA has validated it, even if it ran in a VM, and they check that this is an actual problem, the next step is the engine developer themselves, the team that takes care of this particular area where the issue is filed. And if QA will run things in a VM, unfortunately, they're getting there, the developers won't, because they're not QA. What they get is already sanitized, validated projects from a previous triage step. The level of trust is increased because they're not just randomly running something that just fell off the internet. Someone's already ran it before. So implicit trust in the process means it's much less likely for them to be running this in a sanitized environment. They're going to be running this in a machine that is not likely to be a VM. They need all the tooling. They need the source code. They need the Visual Studios, and they need compilers, and they need all this stuff to debug. It's really hard to do this and be very, very safe and sanitized. So now we come to the developer machine. And do you play games? I know some people play games here. Do you have antivirus running? Do you disable the antivirus when you're playing games, or add exceptions to the antivirus so that the game runs? Imagine that 10 times, because instead of just running a game, you're building a game. You're building an engine. The amount of false positives in antivirus whenever you're compiling anything is ridiculous. Ridiculous. It's really good for when you have viruses, but you can't run build machines with antivirus on, because it will just literally yank out half of the build artifacts whenever you're building, because it saw a signature of something. So I Googled antivirus games, and this is literally the first hit that I found on the internet, which is not, it's bad enough in a user machine. Developers also have to do this. So now you are running potentially whatever code someone submitted in a machine with full tooling, no antivirus, nothing. And not just no antivirus, a developer machine just runs everything. In a infrastructure, you might be able to go like, oh, you're running PowerShell, you might be infected with something. It's just like, no, it's a developer machine. Unity ships with 2 compilers. Unreal ships with 3 compilers. It also, both of them have Node. Both of them ship, like, Unreal ships 2 different versions of Python. Like, literally, this is just the game engines, not mentioning all of the other tooling that a developer machine has. So now you have a developer machine not only runs everything, so you can't even try to figure out if there's something going on in the machine, because literally everything could be could be good or bad. It's probably not a VM, and it has access to all the internal networks. It probably has access to publishing keys, if the developer happens to do that, because it's a high-powered, like it's like the highest trust environment you have, and you're running code in it. So it's problematic. But you say, okay, but it's just game content, right? It's just C#, whatever. Like you're building game content. It's not like you can load any library in the system and do whatever you want as soon as the editor comes up, without even having any control over what gets loaded, right? So let me switch back, and this time I won't break the thing, because I think we're gonna do the demos and done. Unreal. The wrong desktop. Am I extending or duplicating? I'm already duplicating. Okay, cool. So this is the little project that I showed you for Unity. Imagine that this is the project that I submitted. I literally went, help, report a bug, and the bug reporter immediately added all of these attached files, attached folders, like literally added the entire folder, just by default. So in this project, there's C# code, and there's this little DLL that I have here. That is this pre-built binary. That is just there. This is just a standard way of loading native things. You just drop a DLL in there, and then you call it from C#, and it will do something. There's no source code for this, because Unity is not actually building this DLL. Like, you will import third-party SDKs, which include all of whatever binaries they need to work natively. So I have my little scripts, and as soon as I uncomment this, Unity will compile and immediately load and run it, because that's what I told it to do. So if I sent this, I'm gonna imagine I have this project that I sent to a developer with a bug report, right? There's a bunch of code here, and they will go and open it up. Yeah, that's it. Like, the editor's not even fully loaded yet, and my code is already running. This library can have anything. I mean, if you don't want to compile C or C++ to have a native library, that's fine, because this is a full .NET environment. And again, Unity ships with 2 different compilers. So you can literally just use Unity's compilers to compile whatever you want if you don't, or you can just use .NET. It's C#. You can do whatever. Same thing with, where did we have Unreal? Unreal. There you are. Same thing with Unreal. I'm just going to drop it over there. Unreal is C++. So I was lazy, and I literally just did their template code instead of coding anything. I just did new plugin in Unreal, and it dropped a fully compiled the library into the engine. Helpfully compiled. I can change it and recompile it, but it drops a precompiled binary directly that is immediately loaded. Because it's an example, right? It's exactly the same type of model. As soon as the editor loads, it will load and scan all the plugins that are configured to load at load time, and it will just load them. Interestingly, like in Unity, the native DLLs, the source code is sometimes shipped with the DLL, sometimes not. Because in Real is C++ based, all of the code ships. It will do all of the stuff in C++, so all the code is shipping with the DLL. But that doesn't mean that the code matches what the binary has, because the code is going to be compiled after the editor loads, but by that point the binary is already loaded, because the plugin model loads way before all of the user scripts load. So even though this is the original source for that library, you can see that it says that, and basically literally I don't have it compiled here right now, which is why it didn't show any message. So yeah, problem with C++ is that native DLLs, once they're loaded, they are never unloaded ever, ever, ever again until the process goes away. Just FYI, by the way, depending on the OS. And this is Windows. And once it's loaded forever. And Windows will lock the file on disk, so you can't even replace it once it's loaded in a normal loading environment, which is what all of these use. It's, you kind of have to shut down the engine in order to recompile these things, but when they're loaded, they're loaded. So imagine that I compiled that. So that one's compiled. But I'm going to comment it out, not compile it, and then let's run the engine. Assuming I didn't forget to call it. Just check. No, it's getting cold. So again, so if I sent this project with whatever I want in the source, like I can, I could just do that, and I send this, right? That's the source of the DLL that I have in the project, right? Totally. Not really. So by this point, whatever I had in the binary, regardless of what the source said, whatever I had in the binary is loaded, and I can do anything. So yeah. You can see my presenter view. It's fine. So yeah. I'm not sure what the upside of this talk is. They have the slide of mitigations going on there, because the problem here is that it is an exploit of human processes, right? The hot reloading mechanism is essential to the whole game development experience. You need this in order to be able to do the tooling that you need in order to be able to do the game. And the games are so complex these days that all of this stuff is needed. You can't throw it away. But then the processes for triaging whatever things people send to you because they have a bug in their game and their game is 5 gigs, and there will be tens of DLLs at the minimum there, because most of the third-party SDKs that come will have native binaries for directly accessing the hardware. And if it's Unreal, everything is C++. If it's Unity, it will be C# with a bunch of native libraries. Having all of these things is normal. It's a normal process. And the only mitigation you can really do is sanitize and run stuff on a VM and hope that's enough to mitigate this. It's obviously not a common attack vector because the industries are so separate and the way the game industry works is so different from all the other industries that you either are there and you understand how this stuff, like all this stuff is built and run, or you're in other industries and you only see the user side of it. You're making games, not, it's, you know, like all the security in games industry is focused on cheating or the services behind it, the games themselves. The middleware is not a factor, not a vector. Which is why still today, like this process exists as it exists, even though it's getting fixed because these companies are big enough that they understand that this is a problem now, and increasingly they need to mitigate and protect. But yes, so that is the flaw. That is the flaw in the process. And that is my talk. Questions? Yes.
How did you get drawn to this topic? Did you experience and exploit yourself, or how? Because I haven't been aware of the security issues in game engines, and somehow you have to get the attention that this exists.
It's because I work in hot, relatable, like I just do this all the time. Like I running engines that are running languages that are running other languages that are running other languages is a thing that I keep doing all the time. And at some point at 7 p.m. in a pub, I go like, after Blackhoodie actually, it was like, yeah, that doesn't feel safe. Wait, if I'm evil and do, no, this is no. Wait, I've done this because when I was working on Mono, we were literally people would send us applications that were running in Windows, written in C# and say, hey, I want to run this on Linux. Please, can you fix all the bugs required to run this on Linux? And I would just run these apps and fix all the things until they ran properly, right? And I did this over and over. We all did this over and over again. I never once considered what I was doing, once considered what I was running or whether that thing was, and I would never have source. At least on the games you have source, some source. You can see maybe it might, like the DLL might match the source, maybe. When I was getting like, here, port me this thing. I have no idea what that thing is. It's just an application that someone built. I have no idea what it does. I just know it does this on Windows. It needs to be exactly the same on Linux, and then fix everything until it runs. And that's, yeah, it was literally at some point at 7 p.m. in a pub going like, okay, I'm doing this. This is not safe. But it's because I came to security conference and started thinking about it, basically.
Is this on? Yeah, okay. Earlier in the talk, you talked about this 16 millisecond turnaround time, and I think I missed it. Can you explain one more time about how that, like the mechanism behind the delay that would make people nauseous?
It is your inner ear that there's a mechanism in your brain that provides you with the feeling of being in a place and having horizontal, vertical. When you're sitting on a plane and the plane is taking off, you can feel that it's going up, even though there's no sense to that, because you don't have an horizon, you don't have a relative way of figuring out that this plane is doing this as opposed to that. Your inner ear and mechanisms in your brain allow you to have this feeling of I'm going up, I'm sitting on a plane and the plane is going up. That mechanism is interpreting what you see, basically, and all of the other inputs that you have, gravity and everything else. Now, when you're putting on a VR headset, your eyes are like the eyes are like the major source of input. Like they override everything else, basically, in most cases. So when you're putting on a VR headset, you're faking to your brain your horizon, your horizontal and vertical, all of your positioning in the environment, the way that you're moving your head and what should happen when you move your head. Now, your ear and all of these other mechanisms, they know if you're horizontal, vertical, or sideways, because your eyes is not the only thing that matters. So when there's a mismatch between what you see and what your inner ears and your brain mechanisms tell you what should be happening, you get nauseous. No, this is the reason why I brought this topic is to provide an example of why game engines need to optimize for speed and performance, but game development itself does not optimize for speed and performance. It optimizes for content and for experiences. So you have this amount of people building for speed and performance, and this amount of people building experiences and narrative. And the tools that they need are incompatible. The languages that these people need do not serve the needs of these people. So over time, there's the split between the core engine functionality that needs to be fast so you don't get sick when you're on a VR headset, and the tooling and languages that the people that are building the game itself need in order to be able to ship efficiently, to ship the game instead of spending 2 years making a dialogue. No, it's just if you have a computer that's lying to your eyes, you just notice it really much faster than if you're staring at a monitor. So the question was like, what would happen? Why would the headset lie if it's the delay in pixels? Imagine you're downloading some data in order to show something in the VR headset, and the internet goes down, and that thing is, and it freezes the screen for an instance. If you move your head or move your eyes and the headset does not respond within 16 milliseconds, any interruption in this pattern will break you as a human being. So it's not lying as much as it's just an example of this is the thing that you need to do in order not to break humans, and these are the tools that you need to do it with. But the people that are building content, those tools are not efficient for them, and now we get into this state where, you know, hot relatable mechanisms and prototyping for game developers to see their code is useful, but now we have another issue where these mechanisms are nice until someone is evil and does something with this code, basically. Anyone else? Yes, it's over there. Run.
Did you talk to the game engine developers about adjusting their Q&A process?
Oh, yes.
How did they react?
Oh, yeah, that's a good idea. That was literally it. Like, I'm not the only person. It's kind of, these ideas are kind of weird. Someone thinks of something, and then suddenly the next week someone's going like, you know what, I thought of this. And it's going like, yeah, it's kind of percolates. Even like for some reason, some ideas just pop up in people's brains at the same time. Like all of this is obvious. It's not. It's yeah. Okay. This is an actual problem. And I talk to security teams about this. Like, guys, this is a problem. And fortunately, it's not a common vector. It's not something that people think about a lot. So ignorance sometimes is bliss. Not knowing that this is a problem is good. Um, but it just takes time to set up, like infrastructures and stuff. And there's also the belief there's like, that sounds like a lot of work. Like why? Like that sounds like a lot of work, because it is. In order for your bug report to go through into whatever target you want it to go through, you actually need to have a valid bug that people will want to escalate up the chain, right? And to have a valid bug, you kind of have to know the engine, or at least be able to reproduce a bug. Now, the issue trackers are available, and you can go and troll the issue trackers and see if you can find some bug report that you can reproduce and inject into your bug report while you send other stuff there that's not exactly, your bug report. But that, again, it's work. It's not, just easy to do that. So at least that mitigates something. But still, yeah, they know. Yep. Okay. Then thank you.